Introduction to the Pythagorean trigonometric identity. In the figure, you can see a right triangle with the base, length A, the height B, and the length of the hypotenuse C. From the Pythagorean theorem, we know that A2 plus B2 equals C2. In this lesson, we will learn how to relate trigonometric functions to the Pythagorean theorem. In order to do that, first let us pick one of the angles that is not a right angle in this triangle. We can pick this angle. We know that sine equals the opposite over hypotenuse, and cosine equals the adjacent over hypotenuse. Let us first think about the sine of theta. Sine of theta equals the length of B over the length of C, which equals B over C. The length of B, the side opposite the hypotenuse, over the length of C, the hypotenuse, which equals B over C. Cosine of theta equals the length of A, the side adjacent to the hypotenuse, over the length of C, the hypotenuse, which equals A over C. Now, how can we relate this to the Pythagorean theorem? Well, if we square, sine of theta squared equals B squared over C squared, and cosine of theta squared equals A2 over C2. So sine of theta squared plus cosine of theta squared equals B2 over C2 plus A2 over C2, which equals B2 plus A2 over C2. Using the Pythagorean theorem, A2 plus B2 equals C2. So we can substitute A2 plus B2 for C2 in this equation. So this equals C2 over C2, which equals 1. So sine of theta squared plus cosine of theta squared equals 1. Now, this is a useful form of the Pythagorean theorem, the Pythagorean identity. There is another form that is the result of solving for sine of theta. Solving for cos of theta, we have cos of theta squared plus sine of theta squared, which equals 1. Now, if we add negative sine of theta squared to both, then we get cosine of theta squared equals 1 minus sine of theta squared, which means that cosine of theta equals the square root of 1 minus sine of theta squared. You can get this by just taking the square root of this one. So take the square root of cosine of theta squared equals 1 minus sine of theta squared. By taking the square root of that, you get cosine of theta equals the square root of 1 minus sine of theta squared. By knowing this, we can use the formula sine of theta equals the square root of 1 minus cosine of theta squared to find cosine or sine. In this problem, we are trying to find the value of sine of theta. Now, we already have the value of cosine of theta, which is 3 over 5. So we can substitute 3 over 5 for cosine of theta squared in this equation. So sine of theta equals square root of 1 minus 3 over 5 squared. Which equals the square root of 1 minus 9 over 25, 1 minus 9 over 25, which equals the square root of 16 over 25, which equals 4 over 5. So sine of theta equals 4 over 5. You now know how to use the Pythagorean trigonometric identity.